Okay, thanks everybody for waiting a little bit. So as you can see, our next two talks are the end of the day, so we're just going to briefly talk. This talk actually should go by pretty quickly, just about our integrators, our collaborations that we've done, some of our success stories, and just like what people are doing. And then we're going to give a sort of software heavy technical talk on, what we're looking at in terms of a roadmap for 8.0 to help BioGears be more integrator friendly and easier to build, easier to configure, easier to interface with. So that's the last set of talks for today. And then tomorrow we've got Dr. Brett Talbot, who's been on the chat. Great guy. We're looking forward to his talk tomorrow at 9:15. So I appreciate everybody being here and all the feedback. It's been really great. Okay, so BioGears integrators, we just want to first say thank you, integrators. Thank you, people who are using BioGears, who are interested in BioGears. This is one of our primary goals and has been for 7 years, is to help people use BioGears, help people integrate with BioGears. So really quickly, the structure of this talk, I just want to talk about a couple success stories we've had integrating and validating with different groups. So first, our work with the Advanced Modular Mannequin group, primarily the group out of University of Washington and becalm 3D, a small business supporting that contract. And then our work with the U.S. Army Institute of Surgical Research for our burn modeling and validation. And then just a really quick once-over of, what some other people we know are using BioGears. Sometimes it's difficult for us to know who's using BioGears because it's freely available. Anybody can pull it down and start working on it and never tell us anything. So these are our interactions. And of course, we're always encouraging everybody who's on this talk to reach out to me, reach out to Stephen to discuss ways that we can help you. So that's always an option. We're always available. I posted our emails in the chat. Yeah, reach out with us. So really quickly, what did work with the Advanced Modular Mannequin group look like? So first off, we started working with the Advanced Modular Mannequin group on a subcontract with them in order to support some validation and then also support some new models. So that pain model that you saw was a part of this collaboration, as well as the sepsis model, the original sepsis model. And then just additional validation. So basically, they are creating a modular robotic mannequin that, in hopes that it can be sort of the state-of-the-art with physiology, backbone, and interface, the state-of-the-art training mannequin worldwide. And so what their goals are very lofty, and they've really accomplished a lot of stuff. And so really they wanted us to help update and create new models. So that was us working with their clinicians, presenting scenarios, presenting data, figuring out how we could patch BioGears in order to get some of our models more in line with some of their clinical targets they were looking at. Helping them with output data, updating our CDM where necessary. Sometimes they wanted vitals that we didn't currently support on our physiology data requests. So we were able to update some of our physiology data requests in order to allow them to access that data easily. We worked with their team to validate 5 key scenarios that they had identified as being critical to their training for their old contract. They've moved on since then, but some of this work was really key, and then just working on them with them on publications, helping get out the word about BioGears and AMM and some of the great work that they're doing. And then we've also had them as a subcontractor for our prolonged field care project, and we're always trying to keep working with people who really find that BioGears is a useful tool for them. So really quickly, what did one of these scenarios look like? So they were developing an advanced airway simulation module, and they really wanted to make sure that our pneumothorax model, because BioGears is running in the background of all of their mechanical mannequin simulations, they wanted to make sure that this pneumothorax model was well validated for many different severities, and then for each severity, many different treatments. So they identified 4 severities: a mild tension pneumothorax, moderate, and severe, with associated intrathoracic pressures that they gave to us. And then they wanted us to kind of run a set of scenarios associated with those. And they actually ran these in-house as well. We helped them a little bit, like getting the scenarios together, but they had fellows at the University of Washington, at University of Minnesota, and at becalm 3D that were able to run these scenarios, look at the data, create reports, and then kind of get back to us about, you know, what they were seeing, what was good, what was bad, and what that we needed to do to help with some of this stuff. So then they wanted us to run the pneumothorax to kind of get this injured patient state. And then they wanted one protocol where we turned it on and then off, one protocol where we turned it on and then we used a needle decompression or chest tube intervention, and then run that for 3 more minutes. And that was for each of these severities. And then really it was great because we were able to update our respiratory driver based on a lot of the feedback that they provided to us. It wasn't just that feedback, but some of these key features that they were looking for with their respiratory mannequin, and some of those driver updates to the respiratory system were introduced in version 7.2. So we're on 7.3 now, just for reference. So what that looked like, so we wanted to make sure that they could repeat these processes over and over and over again. So sometimes that was our team interacting with their team and helping them template a scenario file. So on the left side, that's our scenario file. Okay, we're introducing attention pneumothorax data, closed, right side, severity level 3, run it for 3 minutes. So you can see that when they templated their scenario that they were looking for, we could then get back to them very quickly and say, okay, here's your scenario file. Once they were up and running, they're able to run this over and over and over again, adjust severities, adjust timing profiles. So the key is repeatability here. And so as in BioGears is deterministic. It's, you know, not a stochastic process. We don't have stochastic models within BioGears, but we do have scaling for patient variability. So if you put a different patient in, you'll get a different outcome. But as long as you keep running this over, they can keep assessing minor changes. It's sometimes it's these minute details that they're really looking to key in on. And then the bottom panel, you can see tension pneumothorax, and this one's severity of 1. So this is a much more severe pneumothorax, and they were able to run those and collect the data that they wanted. So we handed those off to their team. They're able to rerun it and adjust how they wanted. This also led us to create new how-tos. So usually when we interact with the community, we are able to create how-tos that allow people to see how you would use our programming interface in order to program something like this. So if you were thinking about an application on the web or on a microcontroller or robotics, this is the C++ code on the right-hand side that you would need to set to create a tension pneumothorax. So not only is BioGears like just this computational model, we also try really hard to make sure that our API is clean, easy to implement, and easy to get up and going. So you can see you can set these tension pneumothorax with 5 lines of C++ code. So that's really the hope. And you know, when it's not a lot of overhead. So when small businesses or somebody else approach us, it's straightforward for us to engage with them and get them something that they're happy with. And then so from there, they were able to plot results. They were able to adjust severities, give us feedback. These are results from the engine version 6.3. So these are actually not completely accurate for what we were doing, but this was when we were interacting with AMM at the time, about a year ago. We still interact with them quite often, maybe weekly. But so this was a 6-minute closed tension pneumothorax. You can see the tidal volume and the respiration rate responding to those pneumothorax. The initial insult creates this decrease in the tidal volume. You can see the respiration rate expanding and increasing as oxygen saturation is decreasing. So the tidal volume takes a hit because there's not as much volume going into the lungs, and then the respiration rate is also being adjusted by the nervous system within BioGears to respond to that insult. So this they were looking at being used as a training tool for needle decompression for their robotic mannequin, but they needed to make sure that the background physiology was appropriate, and I think we were close, and we made some small adjustments. We've made bigger adjustments since then, not necessarily to address tension pneumothorax, but to address some other carbon dioxide levels in the blood and responses to that. So, but you can also, imagine that you create, scenario files that can be used as research tools to investigate certain things. You want to run them over and over for different patients. That's kind of how you might template like a clinical trial or something like that. So then they wanted us to develop a sepsis model. And again, actually the values that Matt was showing in the earlier talk are our most accurate sepsis model, because we actually adjusted this model when we created the burn inflammation model to just have this sort of systemic inflammation model that both burn and sepsis could kind of play into. But originally, what they were able to do is kind of give us an idea of what they were looking at and what they wanted to do with this model. So they wanted to see a fast progression in the gut, and this is where we started scaling severity with their clinicians in order to get something they were happy with. And then they wanted a fast progression with treatment, and this treatment, they wanted us to mimic early goal-directed therapy. And so this speaks to Dan kind of talking about validation. It's always hard to validate something like this, especially when you have multiple interventions and you don't necessarily know what those outcomes are going to be. But okay, so we wanted to follow this therapy that was directed to us by their team of anesthesiologists and clinicians. And so we began with sepsis, we administer antibiotics, we administer saline, and we titrate that saline based on certain functions that are happening in terms of blood pressure, and then we started a norepinephrine infusion. Actually working with them allowed us to create the norepinephrine drug, which we didn't have in BioGears before this. But because of the generic structure of our substances, we actually got up and running with that drug really, really quickly. And then when they create these scenarios, they also create an expectation, right? They're like, okay, when I administer saline, I would expect the physiology to go a certain way. Now, obviously, that's not necessarily ground truth, but coming from their team of clinicians and people with very, very experienced in ICUs and treatments of sepsis, we were very comfortable creating this model for them. And so originally what this looked like was this. We had antibiotics in the body. We had a norepinephrine administration. The antibiotics were cleared. This is generic. Matt has now extended antibiotics to become their own substance with clearance. This was, we created an antibiotic initially just to interact with sepsis, but now it's kind of a drug that you can give generically. It still interacts with sepsis, obviously, but it's not made just for sepsis. So you can see our mean arterial pressure dropping, but as the treatment therapy progresses, you can see that the mean arterial pressure started increasing, the blood volume started increasing as the antibiotics resolved and as the norepinephrine resolved. So it was these kind of timelines where they wanted to see mean arterial pressure for many, many different interventions, blood volumes, and they wanted to make sure that what they were seeing looked good. And I've actually been told recently that they've done testing with their advanced airway trainer at a base in San Diego, and that the physiology is in a place where it's, as trainees are going through the process, nobody's being taken out of the experience, which at least tells you that the physiology is tracking with what is expected of a patient, a general patient experiencing the trauma and treatments that we're giving them, which was always a good sign for us. So our next one was work with ISR. So our work with ISR started with our burn care model, and we wanted to develop a burn inflammation model, and Matt really did a great job extending the burn model to be a generic inflammation model that then sepsis could also play into as well. So the inflammation in the body, if you have sepsis and a burn, will actually compound with each other. This also included us updating new scenarios, creating more complex how-tos, always with the user community in mind, updating our CDM model to make sure that output data that they were interested in specifically was being provided to them. And then we worked with their team in order to make sure that the burn model we were creating was highly accurate and as good as we could make it with their team. And we had, some of the leading experts in their burn trauma center working with us on the outputs here. We made sure to document this process in terms of publications that people can now reference, and hopefully we would like to continue working with them in the future because they've really added so much to BioGears. And that's like the key of this talk is that as more and more experts can come to the table and help us and work with us, BioGears just keeps getting better and better, and that's the whole point. So the timeline that they wanted us to look at initially was a multi-trauma scenario, and Nathan's going to give us a really good overview of multi-trauma scenarios tomorrow. But really what they wanted was a point of injury with a fairly large TVSA burn, but a patient who is burned in such a way that they should be able to be resuscitated, and a mild hemorrhage due to shrapnel. They also wanted a tension pneumothorax to slowly resolve during the scenario, and then they expected to be treating this patient with blood infusion, Ringer's lactate, ketamine, and a needle decompression, and then finally finding the slow hemorrhage and treating it. So you can see that this scenario and timeline that they created was quite complex, but it was constructed in such a way that they approached us and said, this is something that I might see in my Role 3 trauma tent, in Syria, or something like that, where we're really getting at a treatment scenario that is real life, that is something that they have tangibly seen and interacted with. And this is really the difficulty with creating all of these models is how do they play with each other? How do they interact with each other? Because oftentimes, like Dan was getting at, you don't have a paper that tells you what that interaction looks like necessarily. And so oftentimes you really do have to just leverage subject matter experts to create something that is appropriate. So we were able to get them a few endpoints, and I'll just introduce a couple of them here. So for this multi-trauma event, they wanted to see the blood volume. So when the patient first came in, I think it was maybe 6-hour transport or something, maybe 4-hour transport. So when they received the patient, the burn has been resolving and causing inflammation, tissue damage, and that fluid to be pushing into the tissue. So you can see that when we first get the patient, they've already lost a lot of their blood volume. So we begin the blood infusion. We color-coded this to give to their SMEs so that they could see where each interaction happened. Then we end the blood infusion. We're able to stop the hemorrhage. And then you can see the coloring is based on the fluid regime that we had. So we had blood infusion initially, and then it was a Ringer's lactate that was adjusted appropriate with the urine output. So we were looking at the urine output, and what they wanted us to do was follow a protocol where we were titrating that up and down in order to kind of achieve that goal urine output that they'd be looking for if they're treating a patient like that. And then we present this to their SMEs. We get feedback. We got interactions. We're able to go back, maybe look at our model, look at areas we can make this more consistent, more realistic for them, and then basically create the best model that we can. And this is a great image of a slide we gave their the subject matter experts there, but we had a real question, which was, if you receive a patient like this, and this was systemic vascular resistance, but you could also look at mean blood pressure here. How would the patient respond if they are this kind of hurt to ketamine infusion? And this was kind of where we were like, would you expect such a jump in blood pressure from an initial ketamine infusion? And actually, you know, it's interesting because one of their main field surgeons that we were interacting with was like, well, it kind of depends. Like, maybe I would, if I gave ketamine to somebody who hadn't decompensated so much, I actually would expect some of a jump like that. But if they were kind of pretty rough and looked like they had decompensated a lot, you wouldn't see quite as dramatic of a jump. So then we're able to go back and kind of adjust the ketamine PD parameters in order to kind of play into that. And what this kind of got to for our modelers is that actually there's kind of this oversaturation of the nervous system, where the nervous system is not going to necessarily maybe respond as well to the ketamine infusion in terms of what you might see from the blood pressure. And so this was just a really great interaction with them. And then we were able to kind of present for all of this burn and treatments. We were able to make this validation table, heart rate, respiration rate, hematocrit. You'll see another page here where they were giving us, okay, I would expect increases here, decreases here. Here's a paper that might reference how that would behave. So this is a very involved process, and I think it's great that Dan asked all those questions, because this is how hard it becomes to validate something when you have so many insults and injuries compounding on a patient. There are many markers that they're looking at. All of these things are changing, and actually BioGears did really quite a good job here being able to project a lot of these numbers when we did the initial burn model. Here we had one unclear block where it's the ketamine bolus and it's the systemic vascular resistance, and then some of our pneumothorax behavior to blood pressure was a little bit strange. Oh, that is the, okay, so I believe GB was the initial of one of the SMEs we were working with. What was, the superscript. I know what you mean. I can't remember his name. I think it was one of them. I think it references one of the SMEs, a person, yes. So so their team, they had we had a team of, I think, 4 that were helping us fill out this chart for them, and so our references were, had to do with what they were telling us. So, and then one of them might have been a paper too. Matt, if you remember the specific details, you can put that in the chat there. Thanks, Dan. So yeah, this is a really hard problem, and you can see like the extent of all these parameters. 3 by 20 or so. We have about 60 pieces of data that we are trying to get to them in order to create a realistic burn multi-trauma scenario for them that they would expect from a patient being received in critical condition. So it's been really great, and I think the process is good for people to see. Just real quick, a shout out to becalm. They've been a great help with BioGears. They helped integrate BioGears into the AMM project. They've really helped us with validation, just like up and down the board. They're always willing to give us details and reports that they develop. Respiratory scenarios specifically, they've been great for. A lot of our respiratory driver updates were driven by some of the reporting we were getting from them. Our burn modeling, I know that I think they've been able to leverage it. They do great work, so I just wanted to make sure that that we gave them appropriate credit, because they're a great small business and they've done great work with us, and they have a great team there too. So if you'd like to reach out to them, reach out to them. And I think Ed and Doug from becalm are on the line, so feel free to put in your details if you'd like. And then documentation. So involved in all of this is our GitHub page, our releases page, all of our documentation that we try to provide to the community, so you can see what we're doing. You can see how BioGears is progressing in real time. Look at our model limitations, look at our equations, look at our validation. Go to our GitHub and post issues. If you have issues, if you're having trouble building, just go to our GitHub page. Really quickly, I can just show you. So this is our core engine page. If you have an issue you'd like to report, just come up here onto issues and click it. We've had 9 of these that we've closed in the past few months. Just come up here, open up an issue, and there we go. GP is golden path treatment, which was documented with SMEs at ISR. Awesome. Thank you, Matt. Great work with the burn model too, Matt. So just open an issue. Create a label for it. However you want to do it. Is it a bug? Is it an enhancement? If you're like, hey, I'd like to see BioGears have this new feature, just fill one of these out with an enhancement tab and say this is what you'd like to see. Even if we can't necessarily get to that enhancement, it's always nice to see that documentation so that we can later go back to it and address it if we have time to do that. So then our BioGears main page is here. You can see that our core is our core engine, but I just kind of wanted to give an overview of like how integrators can get in touch with us. This is our paper data that Christy recently referenced. So you can look at Conference 2020. This is the data set she created for her AI/ML EHR data using BioGears. So go ahead and download that. It's free. Core, here's our user interface. And then the PFC scenario has had many different projects that have been developed here. KinCan, if you're looking for a Python 3 version of a XAPI learning record store, you can pull that down. All of these things are maintained and updated. You can go into core. You can click on commits. You can see how many branches we have currently in development. You can see, the work that we're doing, the pull requests we're getting into. I mean, you can see how we are trying to help the community. You can see people making commits to our methodology, to our models, to everything. So I really encourage everybody to participate and stay involved, and I really appreciate everybody being here. So thanks again. Generic thank you slide. But yeah, I really appreciate it. Any questions? Okay, so then we will move ahead with our next talk, which is the 8.0